record, and there we go. We're recording. You're free to get started.
Okay, thanks, Dr. S. Good evening. My name is Jesse Garn. I'm the team lead for Group 1. It's our pleasure to present to you Microsoft SQL Server. Up first, we have Dylan Connor, who will explain some of the tech specs and features of SQL. Dylan?
Thank you for that, Jesse. I do appreciate it. So let's go ahead and dive down into the technical specifications. Now, the SQL Server, if you're talking about the SQL Server, like SQL Management Studio, the database aspect of it, that can be ran on multiple different operating systems like Windows 8 or higher, or Windows Server 2012, as long as it has the 4.6.NET framework or higher. Now, if we're talking about the actual SQL Server itself, that's an operating system in itself. So you have Windows Server 2012 or 2016, which should be released later. Some of the hardware specifications that it needs is a 6 gigabyte hard drive space, and that's the initial space that you need. Now, you can have what I would suggest is have several terabytes of drives within your SQL Server, because you will be using that space to store all your data from whatever you're doing, whether it's in the retail industry, the health industry, whatever it may be. You need to make sure that you have all of that information. The second thing that you need to do, make sure you have, is 4 gigabytes of RAM, and that is at least 4 gigabytes of RAM. I would also suggest to go from 16 to 32 gigabytes of RAM, just because if you're doing multiple calculations through data and having several writes and reads to your data system, you will need more RAM to do that. Processor-wise, a simple 64 1.4 gigahertz processor is fine for a small system, but if you choose to scale to do scalability or grow bigger than that, a 2.0 gigahertz or higher will be more efficient in doing that, and we'll talk more about that in the features section. Lastly, the processor can either be Intel or AMD, depending on what your personal preference is. Now we're going to go ahead and go over to some of the features. Some of the features that we have is you can have real-time transactional processing with SQL. This means that the front end can read and write constantly to your database. SQL Server is also secure and compliant with all the latest security requirements that are out there, and is one of the top performers in the TPC-E workload. When you're running 640 processors at one time to do transactional computations that you're doing, then yes, the 32 gigabytes of RAM that I talked about before will come into play here. Now, the SQL Server also gives you the ability to have business intelligent models straight out of the box, and it has built-in analytics, so you can actually dive deeper into your data, understand it more, and analyze it more. Also, it is easy to use tool with the syntax based on which we'll get into later for doing SQL queries and everything. It is very easy to use for someone who doesn't really have a lot of knowledge when it comes to a SQL Server. I'm going to go ahead and pass this on to Pharaoh.
Thank you, Dylan. Well, as far as the total costs go for acquiring the SQL database software, it can be around $3,000, and that's in American dollars according to the Microsoft website. Or it can be pay as you go if it's based on Windows Azure. So basically, if you would like to acquire the SQL and you have to pay for it, you can just go to the Microsoft website and you can buy the software itself for around $3,000. Or you can pay as you go if it's Windows Azure. I would prefer Windows Azure because it doesn't require any upfront costs, and you can just pay based on usage. And the same is similar if you're gonna require the maintenance of the SQL database as well. So the cost requirement to maintain the database can differ based on usage as well, and that's only if you are going to be using Windows Azure for that. And you can start with no upfront cost, and it can start from $4.99 per month based on usage, and it can go up from there. And all that is cloud-based, so there is no help, there is no overhead cost, and there is no office maintenance cost. Everything is stored in the cloud, everything is used in the cloud, so you don't have to do much around trying to set up everything. As far as the cost required to troubleshoot the SQL database, that can be free if it's based on community support, or it can be pay as you go if it's based on Windows Azure. So if you want to pay as you go, like I said, there's no upfront cost. You can just go for Windows Azure, and it can be pay as you go, depending on usage and traffic, or it can be per minute billing as well. And that's all accessible through Windows Azure. The pricing is very flexible. But it all depends ultimately on the usage and traffic, and it depends on the size of the organization. So if your organization is a large organization, then you would have to have more traffic, and you would have to have more usage. And if you are going to have more traffic and more usage, then your costs are going to increase. So I would definitely recommend that you go for Windows Azure, because it's cloud-based and you don't require that much amount of money right away. So if your usage increase, then you'd have to pay more money. But if your usage doesn't increase and it stays the same, then your prices are not going to increase as well. That's it for costs. I'm going to pass it on for the next speaker, who's the Jennifer.
Jackie, thank you, Pharaoh. So one of the perceptions of SQL is that it is relatively old school. And what I mean by that is the more data that you need, the more servers are required, which can get relatively expensive pretty quickly if you have a lot of data. Other databases and languages have been created to better accommodate the data that is found more frequently in sites such as social media or search databases like Google. The entries that are within the database, the steps that you have to go through to manipulate each of these entries can be very cumbersome, requiring repetitive entries for each and every task that you attempt to complete. It's not a good fit for large databases, just simply because of the way in which the language requires you to communicate with the database. One of the other databases that have been created to better accommodate things like social media and Google is called Hadoop, and it basically simplifies this. So it's definitely something recognized in the community. At this point, I'm going to pass it off to Sam.
Thank you, Jackie. Now we're going to touch on the overview of the user interface. And if we go to the next slide, we can see there that what the command line interface looks like and what you would input. And in this example, we have several columns that are being taken from the table called table name. And in the next slide, we can see the actual user interface. And here, this is what a Windows system would look like, just generally. And then on the next slide, we can see what a Linux or Mac system would look like for a GUI. Going to the next slide, we can see that there's many different flavors of GUIs for any operating system. Also, the GUIs look different, but the syntax is always the same. A GUI can help a developer to develop queries much faster than typing and have less mistakes in it. Is it intuitive? I would say SQL is intuitive if you're a developer, but if you're an average person like myself, it's not what you would say intuitive. The databases are supposed to mimic speaking English, and some of the new features, there are many new features with the upcoming 2016 SQL, but the ones I could understand were integration of help from online communities, new activity monitor with filtering and automatic refresh, and an integrated database mail interfaces. And that is the overview of the user interface, and I'll pass it on scalability to Jesse.
Hey, thanks, Sam. When we talk about scalability, we're talking about the application's ability to take more resources and do more work. SQL Server does this very well. There's two strategies in scaling SQL, scaling up or scaling out. To scale up, you simply provide the server with more resources like RAM and CPU, and it's able to handle a greater workload. This works great in many cases, and as a benefit, you've only got one server and one database to manage. But what do you do if you're Amazon or Google and the biggest, baddest box you can buy won't handle the workload? The solution is to scale out, that is to spread the workload across many different servers. The process of splitting or partitioning a database across many nodes is called sharding. Some common strategies for splitting the data are to do so by data type, by geographic location, or just right down the middle. By adding nodes and partitioning the database, SQL Server can be scaled to handle very large workloads. That concludes our presentation of Microsoft SQL Server. We hope you found this presentation to be informative, and we thank you for your time. We'll now turn it back to Dr. S.